Hello and welcome to the video on calculus. I'm Arnav Sawant and I'm looking forward to teach you the most interesting topic in physics and mathematics. So what is calculus? So calculus is just a tool in mathematics and physics which helps you to evaluate the world around you more precisely. So you are given a data in a graph maybe, so you can evaluate the area in the graph or the slope of the line in the graph. One such tool, yeah, that you may be familiar with is geometry, trigonometry, etc. Anyways, so what is calculus? Imagine you are in a plane and you have nothing to do, so you calculate the speed of the plane at every instant. Say the speed of the plane is constant. Sorry. Yeah. So you plot the speed of the plane at every instant, and the speed of the plane is constant. Say 1,000 kilometer per hour. So here's the y-axis, and here's the x-axis. So the y-axis represents the speed of the plane, and the x-axis represents the time. So as said earlier, the speed is constant for the plane, which is 1000 kilometer per hour. So the line which shows the speed at every instant will be somewhat like this, which will be a straight line. If I ask you what is the distance traveled by the plane in 3 hours, so you'll say the formula for distance is speed into time, and speed is constant, that is 1000 kilometer per hour. So for a 3-hour interval, let's say here is 1, here is 2, and here is 3. So for a 3-hour interval, the distance traveled will be the multiplication of the line here till this point, and the line and this line right here, which meets at 3. So the area in this graph, let me draw it more neatly. So the area in this graph, which is the green portion, will be the distance traveled by the plane in the 3-hour interval, because the speed of the plane is constant. Now take another example. You are in the same plane, but somehow you start calculating the speed of the plane before it is taking off. So from the point it is taking off, sorry. So at time 0, the plane is at rest, and it is the speed of the plane is increasing till it reaches 1000 kilometer, and then it is constant. So this point right here is 1000, and this is the first hour, this is the second hour, and say this is the third hour. So you have calculated it for the 3-hour interval. At every instant the plane is accelerating. So this is the 3-hour mark, and then I ask you again, what is the distance traveled by the plane in these 3 hours? So here's the speed, and the x-axis, sorry, this is the time. So you'll say I have to multiply the speed, which is this line, and this line, so it will be the area under the graph. So the area under the graph, or the area of this shape right here, but this is not a regular shape, it's an irregular shape. So the area will be the pink portion right here, which will be the distance of the plane traveled in the 3-hour interval. but this is not a regular area, so we can't apply the rules of geometry to find the area of the portion, the shaded portion. So you go ahead, you make these areas as a three different instances of time, with every hour or a different instant. So you take it as every hour different. Yeah, so this is the first hour, this is for the second hour, and this will be for the third hour. And you say that now this is a regular structure. The first hour, this structure right here is a triangle, a right angle triangle. This second structure right here is a trapezoid, and the third structure is somewhat like a rectangle. But I'll tell you that this is not a perfect rectangle, or this is not a perfect trapezoid, because one side of these shapes is not regular. The one side is somewhat curved and wavy. So you say that I take one more segment in this. I divide it into two. Each segment I will divide it into two, and I will take the parameter as lower, means like a half an hour parameter. So I take each segment of half an hour, and I divide it into six segments. And you tell me that this is a somewhat better trapezoid, a somewhat better rectangle, a somewhat better triangle. So you want to find the area of this. In the next case, I ask you what is the acceleration at each instant. So here's the same graph. Let me draw it first. So here's the same graph of the plane. It is moving with the same velocity at the same instant. And this here is 1000. Yeah. So I ask you what is the acceleration at time 60th minute. So at the exact time 60th minute. So here is the 1 hour mark, 1 hour, which is 60 minutes. So this is the 1 hour mark, and I ask you what is the acceleration here. If I ask you what was the acceleration here when you calculated the speed of the plane at every instant when it had a constant speed, then you must say it is 0, because the slope of the line is 0. What is slope? It is the change in y with respect to the change in x. So it is delta y divided by delta x. So here delta y becomes 0, because the y coordinate is not changing, it is constant, which is 1000. But in this case the delta y is changing, so the slope is different. But the delta y is not perfect, it is somewhat curvy. So what can we do for this? We can't find the slope of a curved object. If I tell you that you have to find the slope of this straight line or this straight line, you can tell me easily by the formula y2 minus y1 divided by x2 minus x1. But somehow if I tell you find the slope of this line, then you will tell me it's not a line, it's a structure, a curve. Then its slope is always changing, means it's not constant. So how can I find the slope? So I tell you find the slope at a particular point, say this point right here. So you don't know how to find the slope at a particular point. So by now you will be familiar with the concept that every curve, let it be every curve in the universe, it is associated with an invisible circle. So any curve will be associated with an invisible circle that we cannot see, but it is associated. So this curve also right here, will be associated with a very big circle. If it's a straight line, it is not associated with any circle. But even if it has a little curvature, then the fact that it has a curvature is associated with the circle. So if it is associated with a circle, we can draw a tangent. If you're wondering what is a tangent is a line which touches a circle at only one point. So this line which I am drawing right now is a tangent. It touches the circle at just this point. So we have to draw a tangent at this line. So we know by now that we have to draw a tangent at this point, which will be like this, which will be a straight line. So we can calculate the slope of it. Another approach that you can take is, there is a curved line, and we take 2 points, point A and point B. Similar to the approach we take in calculating the slope of a straight line. We take 2 points, we take the y component of the both the lines, the x components of the both the lines. The x component in this case will be this, the y component will be this. So we divide the change in the y component by the x change in the x component. So here if we take the two lines, or the 2 points in the curve, then we can join the 2 points and have a straight line. But if we find the slope of this line, what about the area in this portion? We are having a discrepancy in the slope, because it's not accurate. It is an approximation we have made. We want the accurate slope. Now you think that this is the same line. I'm drawing the same line right here, and I decrease the difference in the distance in the 2 points. So I take point 1 somewhere here, and point 2 here, and I join these 2 points using a straight line, and I get a little less discrepancy or an approximation. It's a little more accurate. Now furthermore, I further decrease the distance between the 2 points, which is this much, 1 point, second point, and I join the points. Now it is more accurate. So somehow if I take infinite number of segments or infinite number of points in this line, so I take point 1 here, and I take point 2 infinitesimally at a small distance, at a infinitesimally small distance from point 1, and if I join the 2 points, let me take it here. If I join the 2 points which are at a infinitesimally small distance, so it will be accurate. So if I take infinite points which are joined, and then if I find the slope of those points, the lines joining the points, then I may get so these are the lines, and I can get the slope of the points in the curves. So also these points right here, the slopes of the lines can be the tangents of the circle to which the part of which the curve is a part. So that will be the tangent, the slope of the tangent of the circle. This may be a little confusing, but take your time, contemplate about it, and we'll meet in the next video.